A story can be a vault that holds memory for 10,000 years. For generations, Western science dismissed indigenous oral traditions as simple folklore, charming myths with no basis in historical fact. But what if these stories are not myths at all, but meticulously preserved records of real catastrophic events, memories passed down with stunning accuracy across hundreds of human generations? This presents a profound historical mystery. How could non-literate societies possibly maintain precise knowledge of earthquakes, volcanic eruptions, and rising seas across spans of time longer than most written histories? The answer challenges everything we thought we knew about memory and history. By the end, you will understand the sophisticated systems that turned spoken word into a living geological database, and see the hard evidence that proves these ancient narratives true. We will uncover how a spirit battle describes a massive earthquake, how a dreamtime story maps a drowned coastline, and how a sacred tale recalls the fiery collapse of a mountain. What does it mean for our understanding of human history when a story becomes a key to unlocking the deep past? To understand how a story can survive for millennia, we must first untangle a fundamental difference in how time itself is perceived. In the Western tradition, history is a straight line, a sequence of dates marching forward from a fixed point in the past. We anchor events to numbers, to years on a calendar. But for many indigenous cultures, time is not a line, it is a spiral or a circle, deeply woven into the land itself. Events are not remembered as happening in the year 1000 or 5,000 years before present. They are remembered as happening here in this specific valley, or then when that particular ancient tree was a sapling. Chronology is anchored to generations, to the succession of knowledge keepers, and to permanent features of the landscape that outlive any human calendar. A story might be framed as happening in the time of a certain revered ancestor, or before a river changed its course, or when a mountain still had a different shape. This creates a temporal anchor that is incredibly stable. Calendars can be forgotten, numbering systems can fall out of use, but a mountain, a river bend, a distinctive rock formation, these remain. They are constant reference points in a living, place-based memory system. This isn't a lack of historical sense, it's a different, and in many ways more resilient, framework for preserving the sequence of events. The story isn't floating in abstract time, it is physically rooted to the location where the event occurred, making the memory inseparable from the geography itself. This turns the entire landscape into a historical document, one that is read not with eyes but through story. So when a narrative speaks of a time when the sea rushed in to claim a coastal plain, that memory is tied to the very coastline that exists today, offering a direct, tangible link between the present landscape and the ancient event. The past isn't a distant country, it's a layer of meaning inscribed on the world right in front of you. This profound connection between story and place created a powerful anchor, but it alone cannot explain the incredible precision of these records over such vast stretches of time. To achieve that, cultures developed something far more sophisticated, a true technology of memory. These were not casual tales told around a fire. They were complex, deliberate systems of information preservation, maintained with a discipline that would rival any modern archive. At the heart of this system were the specialized knowledge keepers. These were not simply elders who knew a lot of stories. They were rigorously trained custodians, often selected in childhood for their exceptional memory and dedication. Their training was an intense, years-long process of apprenticeship under a master. Every word, every pause, every rhythmic beat of the narrative had to be memorized and recited with absolute fidelity. This was not about creative interpretation, it was about perfect replication. The knowledge itself was considered sacred, a collective treasure, and its preservation was a solemn responsibility. To safeguard against error or loss, the information was encoded in multiple, interconnected layers. The core narrative was often set to a specific, unchangeable melody or a strict poetic meter. Song became a mnemonic device, the rhythm and tune acting as a scaffold that held the precise sequence of words in place. Dance and gesture provided a physical dimension, a choreography that mapped the story onto the body and into space, creating muscle memory alongside auditory memory. Art and symbolic designs on tools, clothing, or sacred objects served as visual prompts, each pattern a trigger for a specific segment of the larger narrative. This multi-sensory approach, engaging sound, movement, and sight, created redundant pathways in the mind, making the memory incredibly resilient. Furthermore, the transmission was not a private affair. Critical histories were often recited during major ceremonies in front of the entire community. This public performance served as a communal verification system. Multiple knowledge keepers would be present, and the collective memory of the audience itself acted as a check against any individual accidentally altering the narrative. It functioned like an oral library with strict access protocols and replication rules, where any deviation from the authorized version would be immediately noticed and corrected. The goal was to minimize drift, to lock the vital information into a form so structured that it could survive the passage of centuries without corruption. This was how a description of a coastline before the sea level rose, or the specific sequence of tremors from an ancient earthquake, could be passed down with such startling accuracy. The story was not just remembered, it was ceremonially rehearsed, ritually performed, and collectively safeguarded, generation after generation. The discipline of these oral systems is one thing, but the true test of their accuracy lies in a direct comparison with the physical evidence. Nowhere is this more stunningly clear than along the coastline of the Pacific Northwest, a place of immense beauty built upon a hidden, colossal force. Deep offshore, the ocean floor is slowly diving beneath the North American continent along a feature called the Cascadia subduction zone. This is a geological fault line capable of generating some of the most powerful earthquakes on the planet, events exceeding magnitude 9. The energy released can drop the entire coastline by several feet in an instant and trigger catastrophic ocean waves. Science tells us these megaquakes recur roughly every 300 to 500 years. The last one struck on January 26 in the year 1700, a fact confirmed by tree ring studies and records of an orphan tsunami that hit Japan. But here lies the core of our mystery. That last great quake occurred long before any European settlement, before seismographs, before written records in the region. So how is it that numerous indigenous nations whose homelands span this coast, from Northern California to British Columbia, have maintained vivid, detailed stories about exactly this kind of catastrophic event? Their oral histories did not just preserve a vague memory of shaking ground. They encoded specific, verifiable details that modern geology has only recently uncovered. This is where narrative meets bedrock, and the ancient stories begin to testify with the precision of scientific data. Among these coastal peoples, one story echoes with particular power, a narrative so widespread it forms a shared memory across nations. It tells of a great battle between two immense beings, the Thunderbird of the sky and the whale of the deep ocean. For generations, this was understood as a foundational myth, a story explaining the natural forces of storms and seas. But when researchers began to listen with the ears of geologists, a chillingly precise account began to emerge. The story describes a period of growing tension, a time when the Earth itself felt unstable. Then the great whale dives deep, causing the ocean to pull back violently from the shore, exposing seafloor never before seen. This is the moment of silence before the cataclysm. Enraged, the Thunderbird in the sky responds, striking the whale with bolts of lightning from its eyes and beating its wings with a sound like continuous, rolling thunder. The earth shakes violently, trees fall, and mountains slide. Finally, the Thunderbird lifts the whale from the water, and the sea surges back inland as a towering, unstoppable wall of water, destroying everything in its path. When you map this symbolic sequence against the known mechanics of a Cascadia megaquake, the correlation is not just plausible, it is exact. The initial shaking is the thunder from the Thunderbird's wings. The sudden, dramatic drop of the coastline, which occurs during the quake itself, is metaphorically described as the whale diving and pulling the ocean with it. This exposes the seafloor, a well-documented precursor to a tsunami. The ocean's furious return as a devastating wave is framed as the Thunderbird lifting the whale and hurling it back onto the land. This is not a vague tale of a flood. It is a specific, step-by-step recounting of a complex geophysical event, from the intense seismic shaking to the co-seismic subsidence of the land, to the generation and arrival of the tsunami. The narrative perfectly encodes the correct order of events, a sequence that would be impossible to intuit without having witnessed it. The story preserved not just the memory of terror, but the very physics of the disaster, wrapped in the enduring symbols of the culture's spiritual landscape. It transformed overwhelming natural violence into a comprehensible story of conflict between powerful beings, a framework that made the event memorable, teachable, and survivable in the imagination for centuries. The story of the Thunderbird and the whale is a powerful cultural memory, but could such an event truly be pinned to a specific date in history? For the longest time, this seemed impossible, a tale suspended in the deep past. Then, from across the widest ocean, an answer arrived in the form of a historical puzzle. In Japan, meticulous records have been kept for centuries detailing tsunamis that struck their coastline. Among these documents is an entry for January 27th, in the year 1700. It describes a wave of unusual power that flooded fields and damaged villages along the Pacific coast. But the record holds a mystery. The Japanese scholars of the time noted there was no local earthquake to explain it. They called it an orphan tsunami, a devastating wave that seemed to have no parent quake. For 300 years, this orphan wave remained a geological curiosity, its origin a complete mystery. How could a tsunami powerful enough to cross the entire Pacific Ocean and register in Japan have no known source? The answer lay sleeping in the coastal forests of the Pacific Northwest. Scientists studying these forests noticed something strange. In certain low-lying areas, they found stands of great cedar and spruce trees that had died simultaneously, their roots killed by a sudden, long-term immersion in saltwater. By using tree ring dating, a technique called dendrochronology, they could read the final growth rings of these drowned trees. The story in the wood was clear and unanimous. Every one of these trees had died in the growing season of the year 1699. Given the growing cycle, the lethal flooding had to have occurred in the winter that followed, pointing squarely to the early months of 1700. When they cross-referenced this physical evidence with the Japanese tsunami records, the orphan wave finally found its parent. The timing was perfect. The tsunami would have taken roughly 9 to 10 hours to cross the Pacific from North America to Japan. The wave recorded on January 27th in Japan aligned precisely with a massive earthquake occurring on the evening of January 26th along the Cascadia coast. Science had not only identified the event, it had given it an exact calendar date. And with that date now anchored in the physical world, researchers turned back to the indigenous oral histories. They did not find a date, for the stories do not speak in those terms, but they found something far more profound. The detailed descriptions of the land dropping, the ocean surging, and the communities forever changed. These narratives now had a confirmed historical moment. The Japanese written record and the North American tree ring data provided the independent scientific validation. The oral traditions provided the human experience, the sensory detail, and the cultural meaning of that cataclysm. Two completely separate lines of evidence, one from written archives across an ocean and one from stories rooted in the land itself, converged on the same truth. This convergence transforms the story from a compelling myth into a verified eyewitness account, one that has been faithfully recited for over 300 years. The land itself holds a testimony written in mud and wood, while the oral histories provide the narrative and the Japanese records offer a calendar date. The most undeniable proof lies buried in the very soil of the Pacific Northwest. Here, geologists search for what they call paleoseismic evidence, the physical scars left by ancient earthquakes. Their discoveries have unveiled a landscape that remembers, and its memory perfectly echoes the stories passed down for generations. One of the most haunting pieces of evidence is found in the quiet, waterlogged soils along the coast. Researchers core into the bottoms of coastal lakes and marshes, extracting long tubes of sediment, a layered history book of mud. In these cores, they find a repeating pattern. There are layers of fine, dark organic mud, built up slowly over centuries from decaying plants. But interrupting this calm accumulation are sudden, thick bands of pure sand. This sand is coarse, full of tiny shells, and utterly foreign to the quiet lake environment. These sand layers are tsunami deposits called turbidites. They tell a clear story. A colossal earthquake strikes, the land drops, and a towering wall of ocean water rushes inland, sweeping across beaches and forests and dumping this load of sea sand far into sheltered lakes. Then, as the land recovers, the slow, peaceful accumulation of dark mud begins again, sealing the sandy event layer like a bookmark in time. By carbon dating the plant material just above and below these sand layers, scientists can pinpoint when each tsunami occurred. The data reveals that catastrophic quakes and waves have struck this coast like clockwork, roughly every 500 years for thousands of years. But the Earth's testimony does not end there. Walk into certain coastal estuaries and you will encounter a silent, gray army. These are the ghost forests. They are stands of massive, centuries-old cedar and spruce, all dead, their bark long gone, leaving behind smooth, bone-white trunks. These trees did not die of disease or old age. Their roots were suddenly drowned in salt water, killed by the land dropping several feet during a megaquake, allowing the tides to permanently claim the ground they stood upon. By studying the tree rings of these fallen giants, scientists can see the exact year the trees stopped growing. The outermost ring of a ghost forest tree tells the year of its death, and across vast stretches of coastline, that date is consistently the same, clustering around the year 1699. This creates a chillingly precise picture. The quake dropped a long section of coastline, killing these forests by submerging their roots. Then, minutes later, the tsunami wave arrived, laying down the sandy layer found in the lakes. This physical evidence builds an independent timeline of catastrophe, one written not in words, but in sediment and splintered wood. And when researchers compare this geological timeline with the collected oral histories of the coastal tribes, the alignment is breathtaking. The periods of great upheaval marked in the sediment cores, the dates of the ghost forests, they correspond directly to the eras described in the traditions as times of great change, when the earth shook and the sea claimed the land. The stories do not give a year, but they faithfully mark the event. The geology gives the year and confirms the event. Two entirely different recording systems, one cultural and one natural, are telling the same story of a restless earth. The ghost forests stand as silent witnesses to a single, monumental night. But what if an oral tradition could hold memories not of centuries, but of entire geological epochs, stretching back to a time when the very shape of the world was different? To find such a scale of memory, we must travel to another continent, to the ancient landscapes of Australia. Here, Aboriginal cultures maintain the oldest continuous traditions on Earth, a living connection to a past that stretches back over 60,000 years. This time frame places their collective memory within the grasp of the planet's last great transformation, the end of the Ice Age. As the global climate warmed, vast ice sheets melted and the oceans rose. This was not a sudden flood, but a relentless, creeping change that spanned thousands of years, from roughly 20,000 to 6,000 years ago. Coastlines retreated inland, not by miles, but by hundreds of miles, drowning entire continental shelves and transforming islands into mountains surrounded by sea. The world map was literally redrawn. Modern science has meticulously charted this process through core samples and seafloor topography, but our question is one of human memory. Could any society, no matter how robust its oral systems, preserve a coherent memory of such a slow-motion catastrophe, a change so gradual it would be imperceptible across a single human lifetime, yet utterly transformative across 300 generations? The very notion seems to defy possibility, yet scattered across Australia from the tropical north to the temperate south, Aboriginal nations tell stories that do not just describe a lost landscape, they map it with eerie precision. These are not tales of a sudden deluge, but of a time when the sea was far away and dry land extended far beyond today's shores. They speak of animals that lived on plains that are now seabed, of river systems that now flow underwater, of sacred sites that were once inland but are now coastal or completely submerged. The narratives often carry a tone of profound loss and change, marking the drowning of country as a pivotal event in the spiritual history of a place. For instance, stories from the Gunditjmara people in the south describe a time when their volcanic landscape was connected to an island now miles offshore, detailing the walking routes ancestors used before the waters rose and separated the land. In the north, the Yolngu people describe the Gulf of Carpentaria not as a sea, but as a vast, fertile plain with freshwater lakes, home to specific spirit ancestors before the ocean spilled in from the north. These are not generic flood myths, they are specific geographical descriptions of a world that has not existed for over 7,000 years. The staggering implication is that these stories are not symbolic interpretations of a changing coastline witnessed by recent ancestors. They are the preserved memories of people who lived on that now drowned land, who watched the waters slowly claim their world, and who encoded that loss into narrative so their descendants would remember what was lost and why the shape of the sea is the way it is today. This transforms the stories from folklore into something far more profound, a living cognitive map of a vanished geography. These stories of a lost coastline are not vague legends, they are precise maps of memory. Take the Gunditjmara people of what is now southwestern Victoria. Their landscape is dominated by the volcanic peak of Budgebim, formerly known as Mount Eccles. In their dreaming, the story goes that a great ancestral being, revealed in the form of the volcano itself, emerged from the earth and cast stones of fire across the land. This event shaped the stony ridges and lava flows that define the region, but the narrative continues, describing a time when the sea was far distant, and a land bridge connected the mainland to a great southern island, what we know today as Tasmania. The story tells of the sea eventually rising slowly and relentlessly until it severed that connection forever, leaving Tasmania isolated across the strait. For a long time, this was interpreted as a symbolic creation tale. Yet geological and archaeological research now confirms that during the last ice age, when sea levels were over 100 meters lower, such a land bridge did indeed exist. People could and did walk to Tasmania. The rising waters that flooded the Bass Strait, isolating the island, occurred between roughly 12,000 and 8,000 years ago. The Gunditjmara story does not just recall a flood, it recalls the specific geographical configuration of the continent from an era that predates the pyramids of Egypt by thousands of years. It encodes the correct sequence, land then sea, and the correct outcome, the creation of an island. Further east, the Ungarangeri people hold stories about the meeting of the Murray River and the sea, a place of immense spiritual significance. Their narratives describe the river's estuary as a broad, freshwater expanse that was once far more extensive, with lakes and plains that are now submerged beneath the Southern Ocean. They speak of a time when the shoreline was many kilometers farther out, and of the sea advancing inward to claim these freshwater places. The direction of this advance from the ocean into the river system is a critical detail preserved in the telling. Modern studies of the Murray Basin's geology show exactly this process. As sea levels rose after the Ice Age, the ocean did indeed push inland, flooding the river's lower valleys and dramatically widening its mouth, transforming the landscape the Ungarangeri ancestors knew. The stories serve as a chronicle of this environmental change, marking the transformation of freshwater country into brackish estuary. They are not about a sudden disaster, but about a slow, profound alteration of home, a change so deep it became woven into the lore and identity of the people. What makes these accounts so compelling is their geographical specificity. They are not universal flood myths found in many cultures, they are hyper-local. They name places that exist today, but describe their relationship to the sea in a way that only makes sense for a past geological epoch. The narratives often include details like the routes ancestors walked that are now underwater, or the locations of springs and hills that became islands. This precision suggests these stories are not imaginative reconstructions of a changed landscape, but direct transmissions of lived experience. They are the accumulated observations of generations who witnessed the slow creep of the high tide mark, the salinization of freshwater lagoons, and the drowning of familiar hunting grounds. Each generation would have added its own witness to the collective narrative, the story growing not as a fiction, but as an ongoing record of environmental change, ratified and refined by every new knowledge keeper. The water's direction, the loss of specific landforms, the feeling of a world receding, all of these details were too important to forget. They were embedded in the foundational stories of how the people came to be in their country, ensuring that even as the sea claimed the land, memory would not let it vanish. The precision of these stories finds its most powerful validation not in poetry, but in the hard contours of the ocean floor. Modern bathymetric maps, which chart the underwater landscape, reveal a ghost continent lying just off Australia's shores. This submerged world, known as the continental shelf, is not a featureless plain. It shows the clear, sunken topography of ancient river valleys, dry basins, and coastal plains that were above water for tens of thousands of years. Researchers have begun the meticulous work of overlaying the geographical details from Aboriginal oral traditions onto these maps. The results are startling. Stories that describe, for example, an island that was once a hill on a vast plain align perfectly with a now submerged seamount rising from the shelf. Narratives that speak of crossing from one point to another by foot, where today there is open sea, trace a path across a drowned land bridge visible in the underwater topography. These are not approximate correlations. The stories provide specific place names and descriptions for features that have been underwater for millennia, features that modern science only rediscovered with sonar technology. It is as if these oral traditions contain a cognitive map of a lost world, a map that has been faithfully recited long after the landscape it describes vanished beneath the waves. This alignment between narrative and geology transforms the stories from metaphorical tales into literal, georeferenced records. They are not about a general idea of flooding. They are about this specific river system that used to flow here, and that particular hunting ground that is now a sandbank under 50 meters of water. The land itself, both above and below the sea, becomes the proof of the story's truth. But this raises an even more profound question about timing. Sea level rise was not a steady, gentle process. It occurred in fits and starts, with periods of relative stability punctuated by terrifyingly rapid surges called meltwater pulses. One of the most significant, known as Meltwater Pulse 1A, happened around 14,000 years ago. During this event, global sea levels rose by about 20 meters in just 400 years, a catastrophic rate of change that would have been visibly dramatic within a few human generations. Coastlines could have retreated by kilometers within a single elder's lifetime. It is precisely during these periods of rapid, observable change that the most vivid and detailed flooding narratives are often set. The stories frequently convey not just loss, but a sense of urgency and dramatic transformation, a pace that matches the geological evidence for these pulses. The oral traditions do not give us a calendar date for Meltwater Pulse 1A, but they capture its human-scale impact, the panic of watching a familiar bay widen year after year, the confusion as freshwater springs turned brackish, the collective decision to move ceremonial sites further inland. The timing implied by the emotional weight and specific details of the narratives aligns with the moments of greatest environmental stress revealed in the geological record. This means the stories are not just memories of a changed world, they are memories of the process of that change, witnessed and recorded in real time by the people who lived through it. They represent a continuous line of observation, a multi-generational witness statement to one of the planet's last great geological shifts. When a story describes the sea relentlessly claiming the land, it is likely recounting the lived experience of a meltwater pulse, an event science can identify in ice cores and coral records, but which only human memory can describe from the shore. But how does a culture physically encode a 10,000-year-old memory into the land itself? The answer lies in a concept so profound it redefines the relationship between story and geography. In many Australian Aboriginal traditions, knowledge is not stored in books or even just in songs. It is woven directly into the terrain through what are often called songlines or dreaming tracks. Imagine the entire continent as a vast, interconnected library, where every hill, river bend, and distinctive rock formation is not just a landmark, but a line in an epic poem, a note in a sacred song, a chapter in a living history book. A songline is a path across the country that traces the journey of an ancestral creator being from the dreaming, the formative era when the world took its shape. As that being traveled, its actions created the physical features of the land. A struggle might form a mountain range, a thrown spear might become a river, a place of rest might become a permanent waterhole. The narrative of that journey, memorized in exacting song cycles, becomes a map. To sing the song is to navigate the route, describing each feature in the order you encounter it. The landscape itself is the mnemonic device, an unchanging series of memory prompts. A knowledge keeper walking or singing the songline is not just recalling a story, they are literally retracing the steps of creation, activating the memory stored at each site. This system turns geography into narrative and narrative into a survival guide. The songs contain practical knowledge, the locations of water sources, the seasonal behaviors of plants and animals, and the boundaries between nations. But critically, they also encode historical events. If an ancestral being witnessed the sea rising in a certain valley, that event becomes part of the song for that place. The waterhole that marks the spot is not just a resource, it is a monument to that ancient change. Every time the song is sung at that site, the memory of the event is reinforced, not as a vague legend, but as a truth attached to a tangible, immutable feature of the world. The land, changing only on geological timescales, acts as a permanent, stable archive. You cannot lose this kind of map as long as the people remain on country and continue to practice the ceremony. The story is literally anchored in stone and soil, making forgetting almost impossible, because to forget would be to become lost in your own homeland. This is how a memory of a coastline from 7,000 years ago survives. It is not a floating tale. It is etched into the very path the ancestors walked when the shore was still dry, a path now sung over a seabed, preserving the memory of what was there before the water came. The landscape remembers, and the song gives it a voice. The songlines show how memory can be etched into the earth, but what happens when the earth itself is remade in an instant of unimaginable fury? To find that answer, we must look to the volcanic landscapes of the American West, where mountains can vanish in a single day. The Pacific Northwest is a land built by fire. A chain of volcanoes from Mount Rainier to Mount St. Helens forms a dramatic skyline, quiet now but with a violent past written in layers of ash and hardened lava. Among these giants, one story stands out, not for the mountain that remains, but for the breathtaking void it left behind. Today, we know it as Crater Lake in Oregon, a place of stunning blue water ringed by sheer cliffs. But 7,700 years ago, this was not a lake. It was a towering peak called Mount Mazama, a volcano nearly 12,000 feet tall. Then, in a geological heartbeat, it was gone. The scientific reconstruction of this event reads like a script for the end of a world. Mount Mazama did not simply erupt, it tore itself apart in a series of colossal explosions. The volcano first began to shudder, likely with weeks or months of earthquakes as magma forced its way upward. Then the mountain summit collapsed inward, creating a vast, sinking pit called a caldera. As it collapsed, it unleashed a pyroclastic flow, a ground-hugging hurricane of superheated gas, ash, and rock that raced across the landscape at hundreds of miles an hour, incinerating everything in its path. The ash cloud rose so high it circled the entire northern hemisphere, leaving a distinct layer in the soil that scientists now use as a global time marker. When the fury finally subsided, all that remained was a smoldering crater over 5 miles wide and nearly a mile deep. Over centuries, rain and snowmelt filled this colossal bowl, creating the deepest lake in the United States. This is the geological truth, meticulously pieced together from ash deposits and rock formations, but it presents us with a profound historical puzzle. The eruption happened 7,700 years ago. For a long time, conventional archaeology suggested that humans had only just begun to venture into the Americas around that time, their presence sparse and their journey far from complete. The question seemed almost absurd. Could any human group have been present to witness this apocalyptic event? And if they were, could a memory of such pure, world-ending terror possibly survive across nearly 8,000 years, over 300 human generations? The gap between the scientific date and the timeline of human migration created a mystery. It suggested that if a story existed, it would have to be one of the oldest continuous human records on the planet, a memory stretching back to a time when mammoths still walked the earth. The very possibility challenges the boundaries of what we believe oral tradition can achieve. For the Klamath people, the truth of that vanished mountain was never lost. It was held in a story of two powerful spirits, a narrative that would be recorded by anthropologists in the late 19th century, long before modern geology pieced together the volcanic puzzle. Their oral tradition tells of a great mountain that was the home of Lao, the spirit of the below, a being of the underworld, high above lived Skell, the spirit of the sky and the above. The two spirits, representing fundamental opposing forces of the world, came into a terrible and fiery conflict on the slopes of that mighty peak. The battle was cataclysmic. The narrative describes Lao hurling red-hot rocks and rivers of fire from his mountain home, while Skell fought back with lightning and storms from the heavens. The sky grew dark, not with night but with a thick, choking blanket of ash that blotted out the sun. The air filled with a rain of burning stone and gray, powdery pumice. It was a description of a world ending in fire and darkness. The climax of the story is both decisive and geographically precise. After a final, unimaginable confrontation, the home of Lao, the great mountain itself, collapsed in upon itself, consumed by its own fury. Where the peak once stood, there was now only a gigantic, smoldering hole. In time, rain and snow filled this immense cavity, creating the deep, profoundly blue lake we see today. The Klamath people named it Gewas, a sacred place born from this spiritual war. When scholars first wrote this story down, they treated it as a beautiful and dramatic myth, a symbolic explanation for a striking natural feature. The details of the fiery rocks, the falling ash, the darkness, and the mountain's collapse were seen as poetic metaphor. There was no scientific framework at the time to understand that this was not poetry, but an eyewitness account of a Plinian eruption and caldera collapse. The story preserved the sequence with uncanny accuracy: the eruption column, the pyroclastic flows described as rivers of fire, the ashfall that darkened the sky, and the final, catastrophic sinking of the summit. It captured the sensory horror of the event, the very human experience of witnessing such an event, in a way that raw geological data never could. The narrative provided a cultural container for a memory too vast and terrifying to hold in any other way, transforming a geological process into a moral and spiritual struggle between cosmic forces, ensuring its details would be remembered not just as facts but as sacred truth. The Klamath story is not a solitary legend, but a narrative backed by the unyielding testimony of the Earth itself. For modern volcanologists, the eruption of Mount Mazama is not a mystery, it is a textbook case written in stone and soil. The most compelling piece of evidence is found not just at Crater Lake, but scattered across an entire continent. When scientists examine ancient soil layers from Canada to Nevada, they find a distinct grayish band of volcanic ash. This is the Mazama ash layer, a signature as unique as a fingerprint. This layer acts as a precise time marker in the geological record, a global bookmark placed 7,700 years ago. Any archaeological site or fossil found beneath this ash is older than the eruption. Anything above it is younger. This allows for astonishingly accurate dating across vast distances. The presence of this ash layer confirms the eruption's titanic scale and provides the exact chronological anchor that oral traditions do not. But the science goes deeper, dissecting the event into precise phases that mirror the story's symbolic beats. The initial, sustained explosion that created a towering column of ash and pumice reaching high into the stratosphere is classified as a Plinian eruption, named for the Roman writer Pliny who witnessed the destruction of Pompeii. The Klamath description of the sky growing dark with a thick, choking blanket perfectly captures this phenomenon. Next, the collapsing eruption column generated pyroclastic flows, the ground-hugging hurricanes of superheated debris that the narrative describes as rivers of fire racing from the mountain. Finally, the evacuation of such immense volumes of magma from the chamber beneath the mountain caused its summit to collapse inward, forming the caldera, the great hole where the lake now rests. The story's climax, the mountain collapsing in upon itself, is a direct parallel to this final, catastrophic stage. The alignment is not approximate, it is step by step. The symbolic war between Lao and Skell provides a framework that accurately encodes the complex volcanological sequence of a caldera-forming eruption, from plume to flow to collapse. This is not an isolated case of remarkable alignment. Far to the south, the ancestors of the Hopi people witnessed the birth of another volcano, Sunset Crater in Arizona, around the year 1085. Their oral histories describe a time when the earth bled fire, painting the sunset sky with glowing ash and forcing communities to move. Archaeological sites in the area are found buried under the same cinder layer that gives the crater its name, and tree ring dates from charred wood confirm the eruption's century. Again, the human story and the geological record tell the same tale of a landscape transformed by fire. These parallels reveal something fundamental. When faced with an event of such incomprehensible power, the human mind seeks a framework to contain it, to make it memorable and meaningful. The geological facts are preserved not as a dry list of phenomena, but as a dramatic story of conflict, loss, and ultimately, the creation of a new, sacred landscape. The science gives us the how and the when, but the story preserves the human experience of the why, the awe and the terror of watching a mountain die. The sheer timescales involved seem to defy common sense. If you have ever played the children's game of telephone, you know how a simple whispered phrase can transform into nonsense after just a few exchanges. This is the most persistent and understandable skepticism about these ancient stories. How could a narrative possibly survive 7,000 years or 300 without becoming hopelessly distorted, a mere shadow of its original meaning? The telephone game is a powerful analogy, but it is based on a critical misunderstanding. It assumes that all oral transmission is casual, informal, and unsupervised, a game with no stakes. The transmission of vital cultural knowledge, however, is the precise opposite. It is a formal, ritualized, and high-stakes process where accuracy is not a game, but a sacred duty to ancestors and descendants alike. The difference is not one of degree, but of kind. In the telephone game, the message is arbitrary, the participants are untrained, and the goal is amusement. In the systems we have been exploring, the message is foundational to identity and survival. The participants are rigorously trained custodians, and the goal is perfect preservation. The entire cultural framework is designed to prevent drift. Think of it not as a chain of children whispering, but as a master craftsperson training an apprentice for a decade to replicate a complex, life-saving tool, with the entire community watching to ensure every measurement is exact. The apprentice does not have the liberty to creatively reinterpret the design, because a failure of memory could mean the loss of essential knowledge about water sources, food cycles, or the signs of an impending catastrophe. Anthropological research supports this distinction. Studies of oral traditions in cultures with strong institutional memory, such as the genealogical chants of Polynesian navigators or the historical narratives of certain First Nations, show something remarkable. While peripheral details or stylistic elements might shift over time, the core factual skeleton of an important narrative, the sequence of key events, the names of central figures, and the critical geographical details exhibit minimal drift across generations. The protocols act as a cultural immune system, identifying and correcting errors. A knowledge keeper reciting a lineage or a creation story in a ceremonial setting is not offering a personal interpretation. They are performing a verified text. Other elders present would immediately notice and correct a deviation because they too carry the authorized version. This communal safeguarding, combined with the mnemonic technologies of song, dance, and place-based reference, creates a stable vessel for information. The story of the Thunderbird and the whale is not a mutable campfire tale. It is a calibrated record of a seismic sequence, its details locked into rhythm and symbol because getting it wrong had dire implications for future generations who needed to recognize the warning sign. The telephone game analogy breaks down because it fails to account for the purpose, the discipline, and the profound cultural gravity that surrounds the act of remembering when memory itself is a matter of survival. So the question becomes one of evidence. How can we possibly place a date on a story passed down by word of mouth? Without a written record, how do we measure its age? Researchers have developed a fascinating toolkit for this very purpose, a kind of scientific detective work that cross-references the narrative with independent clocks found in nature. One of the most direct methods is called linguistic paleontology. This involves examining the language of the story itself for frozen moments in time. Think of it as finding linguistic fossils. If a story contains a detailed, accurate name or description for an animal, a plant, or a landform that has not existed in that region for thousands of years, it strongly suggests the story originated when that feature was still present. For example, several indigenous stories from the Great Lakes region in North America describe a large, cow-like creature with great horns that lived in the marshes. The details align perfectly with the now extinct woodland musk ox, an animal that vanished from the area at the end of the last ice age, over 10,000 years ago. The story preserves not just a memory of the animal, but its specific name in the ancient language. This linguistic artifact acts like a timestamp, indicating the narrative's core is at least as old as the last time people and musk ox shared that landscape. Similarly, stories from coastal Australia that name specific islands or hills that are now underwater contain vocabulary for those places that is unique and archaic, preserved only in those ceremonial narratives. The language itself becomes an archaeological layer, holding words for a world that has physically disappeared. Another powerful dating tool comes from aligning story events with celestial or geological calendars. The natural world provides its own fixed timeline. If a story describes a specific, rare astronomical event, like a total solar eclipse or the appearance of a brilliant comet, astronomers can often calculate when that event would have been visible from that exact location. For instance, a story from the indigenous peoples of the American Southwest tells of a time when the sun was swallowed by darkness in the middle of the day, an event that brought great fear and was followed by a period of conflict. Researchers have matched this description to a total solar eclipse that passed over the region in the year 1140. The story's placement of this event within a sequence of other historical happenings allows scholars to anchor the entire oral timeline. On a geological scale, we have already seen the most compelling evidence. The Klamath story of Mount Mazama's collapse is dated by the Mazama ash layer, a geological marker fixed at 7,700 years ago. The story of the Cascadia earthquake is dated by the ghost forests and the Japanese tsunami record to January 1700. In these cases, the cataclysm described in the narrative left an indelible, datable signature in the physical world. The story and the stratum tell the same story, and the science gives us the calendar date for the stratum. This turns the oral history into a dated eyewitness account, its age confirmed by tree rings, ice cores, and layers of volcanic glass. Perhaps the most human-centered method involves listening to the story's own internal clock, the count of generations. Many oral traditions, especially those involving genealogies or the succession of chiefs or knowledge keepers, meticulously list the names in a line of descent. By assuming a conservative average for the length of a generation, often around 25 to 30 years, researchers can estimate the minimum time depth of the narrative. If a founding story is said to have occurred during the time of the 25th ancestor before the present speaker, that suggests an origin roughly 600 to 750 years ago. This method requires caution, as lists can sometimes be symbolic or condensed, but when cross-checked with other evidence, it provides a powerful framework. It shows that the stories themselves are often conscious historical records, structured to preserve not just the event, but the chain of custody for that memory across the centuries. Each named keeper in the line represents a link in an unbroken chain of transmission, a human chronology written not in numbers but in relationships. When all these methods, linguistic, astronomical, geological, and generational, point to the same general time frame, the case becomes overwhelming. The story is not timeless myth, it is a time capsule, and science provides the tools to carefully pry it open and read the date inscribed inside. This chain of evidence, from earthquakes to volcanoes to rising seas, forces a startling conclusion. Our ancestors were not just storytellers, they were eyewitness chroniclers of planetary change. And if their memories could hold the fury of the earth, what about catastrophes that fell from the heavens themselves? The scope of this mystery now widens to the cosmos. Scattered across the globe in cultures with no possible contact are eerily similar legends of fire raining from the sky, of a great flood preceded by a brilliant, terrifying light in the heavens. For generations, these were filed away as universal archetypes, the shared dreams of humanity. But a radical new hypothesis is emerging from the ice sheets and the soil. What if these are not mere dreams, but the fragmented cultural memories of real cosmic impacts, of asteroids or comets striking the atmosphere with the force of 1,000 nuclear bombs? The clues are no longer just in the stories, but in the very chemistry of our planet's memory. Scientists drilling deep into the ice caps of Greenland and Antarctica extract long cores, frozen timelines of the Earth's past. Within these pristine layers, they search for chemical anomalies, the fingerprints of events too powerful to be local. One such fingerprint is platinum. This rare metal is abundant in asteroids and comets, but exceedingly rare in the Earth's crust. Finding a sudden, global spike of platinum dust in an ice layer is like finding extraterrestrial confetti at a crime scene, a strong sign that a large space object fragmented and dispersed its material high in the atmosphere. Researchers have identified one such platinum anomaly dating to around 2,500 years before the Common Era. This date coincides with a period of dramatic, unexplained climate cooling recorded in tree rings across the northern hemisphere. At the same time, sediment cores from over a dozen sites across North America show a sudden, continent-wide layer of charcoal and soot, evidence of catastrophic wildfires that burned millions of acres. The pattern is not of a slow climate shift, but of a sudden, violent ignition. The scientific scenario is chilling. A comet or asteroid, perhaps hundreds of meters across, enters the Earth's atmosphere over North America. It does not strike the ground, but explodes in a massive airburst several miles high, like the famous Tunguska event in Siberia in 1908, but on a vastly larger scale. The thermal blast would have instantly set forests ablaze for hundreds of miles. The shockwave would have flattened everything in its path. The plume of dust and water vapor thrown into the stratosphere would have circled the globe, blocking sunlight and triggering years of failed harvests and global winter. This is the physical evidence. Now we listen to the stories in the oral traditions of dozens of Native American nations, from the Columbia Plateau to the Great Lakes. There are persistent legends of a time when the sky fell. The details are hauntingly consistent. They speak of a great roaring sound from above, of a sun that grew blindingly bright, then vanished behind a cloud of darkness that lasted for days. They describe a rain of fire that consumed the forests and a subsequent time of cold, famine, and hardship that scattered the people. These are not generic tales. The Menominee people of the Great Lakes tell of a fiery panther that flew across the sky, scorching the earth. Tribes of the Pacific Northwest recount the sun being shot from the sky by a celestial arrow, plunging the world into cold and forcing the animals to work together to retrieve a new light. The widespread geographical distribution of these stories, coupled with their specific, shared details of aerial explosion, firestorms, and abrupt climate change, creates a map of cultural trauma that aligns perfectly with the scientific map of the platinum anomaly and the charcoal layers. The stories provide the human experience of the event, the terror of a sun that turned against them, the struggle for survival in the ash-darkened world that followed. They transform the abstract data points of platinum and soot into a lived, remembered catastrophe, a day the sky burned, preserved in the one archive durable enough to hold it, the collective memory of the survivors. The memory of a burning sky is not confined to a single region. Far to the east, in the ancient forests where the Lenape and Ojibwe peoples made their homes, a different set of stories carries the same echo of celestial terror. These are not tales of a distant mountain or a rising sea, but of a catastrophe that came from above, reshaping both the land and the sky. The Lenape tradition speaks of a colossal horned serpent, a powerful and dangerous spirit of the underworld. In one pivotal narrative, this great serpent is struck down, perhaps by a heroic figure or a rival power. But its death is not a quiet end. The story describes how the serpent's immense, writhing body as it fell, scorched the earth in a great fiery path. Then its lifeblood, pouring out in unimaginable volume, flooded the land, creating rivers and lakes from the deluge. This is a story of dual destruction, fire and water, a sequence that feels deeply symbolic. Yet, when placed beside the scientific hypothesis of a cosmic airburst, the symbolism takes on a startlingly literal potential. A comet fragment exploding in the atmosphere could be visualized as a fiery serpent falling from the sky. The thermal pulse from the blast would indeed scorch the Earth along the object's trajectory, creating a path of fire. The subsequent flooding could be explained by the sudden melt of glaciers or ice sheets from the intense heat, or by the dramatic climate disruption that followed, leading to torrential rains and rising waters. The story neatly packages the two-phase disaster, the immediate fire from the sky and the longer-term aquatic chaos, into a single, memorable event involving a mythical being. Similarly, the Ojibwe people hold stories of a time when the sky fell. This phrase is not used lightly. It conveys a collapse of the natural order, a moment when the dome of the heavens itself seemed to fracture and descend. The descriptions often involve a period of darkness, a sun that failed, and a great winter that lingered. Researchers listening to these narratives are not trying to force a scientific fit, but they are asking a compelling question. Do the specific details within these widespread stories align with the physical evidence and the proposed timeline of an event around 2,500 years before the Common Era? The investigation looks closely at the geography of the tales. Do different tribal accounts, when mapped, suggest a consistent direction for the fiery event, perhaps from the northeast to the southwest, which might correlate with a proposed comet fragment trajectory? Do the stories emphasize a particular type of environmental aftermath, such as the growth of certain mosses or the movement of animal populations, that hints at a specific post-catastrophe ecological shift? The oral histories describe more than just fear. They describe a changed world, a landscape that looked and felt different after the event. This kind of detail is gold for interdisciplinary research. When a story says the rivers ran in new courses after the Great Flood, or that the forests were replaced by plains of brush, it offers a testable hypothesis for geologists and paleoecologists. They can examine sediment cores from regional lakes for layers of charcoal from massive fires dating to that period, and then look for pollen samples above that layer to see if the tree species indeed changed dramatically, indicating a long-term climate disruption. The narratives become a guide pointing scientists to where and what to look for in the physical record. This partnership between tradition and technology is delicate. It requires listening to the stories not as flawed myths, but as potential repositories of observational data, encoded in cultural metaphor. The horned serpent is not a scientific report, but it may contain the core truth of a witnessed event, a truth so traumatic that it could only be processed and preserved through the language of deep myth. The falling sky is not a literal description, but it may be the most accurate way a people could describe the sensory overload of an airburst, the blinding flash, the thunderous percussion, and the long, sunless winter that followed. These stories from the eastern woodlands, therefore, are not isolated curiosities. They are pieces of a larger continental puzzle. When viewed alongside the platinum spikes in the ice cores and the charcoal-laden soil layers across the continent, they form a coherent picture of a very bad day, a day that entered history not with written words, but with a warning shriek from the heavens, remembered in the shudder of a serpent's fall and the long memory of a sky that once broke apart. The memory of a sky that fell finds its most dramatic physical signature not in ice or soil alone, but etched directly into the landscape of the American Southeast. Stretching from New Jersey to Florida, scattered across the coastal plain, are hundreds of thousands of mysterious, shallow depressions known as the Carolina Bays. Seen from above, their pattern is unmistakable. They are perfectly elliptical, like giant, watery footprints, all pointing in the same direction, northwest to southeast. They range in size from small ponds to lakes miles long, and their rims are often raised slightly above the surrounding land. For decades, geologists debated their origin, proposing theories from ancient artesian springs to wind patterns over soggy ground. But none of these explanations fully accounted for their uniform shape, their parallel orientation, or their staggering number. Then, in the mid-20th century, a radical new hypothesis emerged, one that connected these terrestrial scars to the cosmic violence suggested by the ice core records. What if the Carolina Bays were not made by slow earthly processes, but in a single, terrifying instant? The controversial theory suggests they are the splash marks of a fragmented comet or asteroid. The idea goes that a large object, perhaps a comet, entered the atmosphere over what is now the Great Lakes region and exploded into a swarm of smaller, still massive fragments. These chunks, superheated and traveling at cosmic speeds, slammed into the soft, wet sediments of the coastal plain. Each impact would have vaporized water and soil, blasting out a crater and molding the liquefied earth into a raised rim, with the elliptical shape and consistent orientation resulting from the low, angled trajectory of the incoming debris. If this theory is correct, it describes a continent-altering event of almost unimaginable scale, a hailstorm of fire from the sky that would have instantly sterilized thousands of square miles, triggered continent-wide wildfires, and plunged the hemisphere into a long, dark winter. And crucially, this event is dated by the sands on the bay's rims to around 12,800 years ago, a time when humans were most certainly present in the Americas. This places a potential global catastrophe squarely within the realm of human memory. The geological puzzle of the bays forces a profound question. If such an apocalyptic bombardment occurred, would the survivors have remembered it? And if they did, how would that memory sound after 400 generations? The search for an answer leads us back to the oral traditions of the indigenous peoples of that very region. Researchers have begun to listen carefully to the oldest stories from nations whose histories are rooted in the Southeast, listening for echoes of that ancient skyfall. Some traditions speak of a time when the stars fell from the heavens, striking the earth with great force and boiling the waters. Others tell of a great, burning wind that scoured the land, or of a period when the sun was dimmed for a very long time, forcing people and animals to adapt to a colder world. The challenge, of course, is immense. 12,800 years is an almost incomprehensible span for a story to travel. It crosses not just centuries, but entire climatic epochs, from the tail end of the Ice Age to the modern world. Languages would have transformed beyond recognition, cultures would have migrated and evolved, and yet the core of a truly catastrophic memory might persist, wrapped in new symbolism but retaining the essential truth of the experience. The research is delicate, requiring deep cultural respect and interdisciplinary collaboration. It is not about forcing a scientific narrative onto a sacred story, but about asking whether independent lines of evidence, one from the land and one from memory, might converge on the same moment of profound change. The elliptical bays on the map and the stories of falling stars are two fragments of a possible past, waiting to see if they fit together. If they do, it would mean our understanding of both human history and planetary history is missing a cataclysmic chapter, one written in the mud of the coastal plain and whispered in the oldest stories of this land. The idea of a cosmic bombardment remains a compelling hypothesis, a mystery written in elliptical lakes and whispered in ancient warnings. But there are other scars on the North American continent, wounds so vast they can only be seen from the air, and their origin is not a mystery of the sky, but a cataclysm of water. In the dry, windswept plains of eastern Washington state lies a landscape that defies belief. It is called the Channeled Scablands, a sprawling, tortured expanse of bare basalt rock, cut by immense, dry canyons, littered with colossal house-sized boulders, and dotted with strange, isolated mesas that look like islands in a stone sea. To walk through it is to feel a profound dissonance, a sense that this is a place where the normal rules of geology were broken. For decades, scientists were baffled by it. The prevailing wisdom said landscapes were shaped by the slow, patient work of rivers and glaciers over millions of years. But the Scablands looked violently young and violently made, as if the earth had been torn open in a fit of rage. The man who finally solved the puzzle, geologist J. Harlan Bretz, faced decades of ridicule for his theory. He proposed that this entire region, an area the size of the state of Rhode Island, had been carved not in eons but in days by a flood of unimaginable proportions. He was right. We now know these as the Missoula floods, a series of perhaps dozens of catastrophic outbursts that occurred between 15,000 and 13,000 years ago. The mechanism was a colossal natural dam. A lobe of the Cordilleran ice sheet had advanced, blocking the Clark Fork River in what is now northern Idaho. Behind this wall of ice, a gigantic lake formed, Glacial Lake Missoula, holding more water than Lake Ontario and Lake Erie combined. Then the ice dam failed. It did not just leak, it shattered. The entire contents of the inland sea exploded westward with a force greater than all the world's rivers combined at any given moment. A wall of water hundreds of feet high raced across the landscape at highway speeds, scouring the bedrock down to its bones, plucking boulders and carrying them for miles, and carving the intricate channeled network in a geological instant. When the waters finally drained into the Pacific, they left behind a naked, humbled landscape, a permanent monument to hydraulic power on a planetary scale. This event happened as the first human beings were almost certainly exploring and settling the continent, which leads us to a haunting question, one that bridges geology and memory. What did the first peoples to walk into this scarred, otherworldly place think they were seeing? They would have had no concept of ice ages or glacial lakes. They would have encountered a land that looked like it had been drowned by gods, a place where water had clearly won a war against stone. Could such a profound, terrifying, and visually obvious event have seeded stories that lasted for millennia? Did the ancestors look at those stranded boulders, those dry waterfalls cutting through solid rock, and craft a narrative to explain how the world came to be so violently remade? The landscape itself is a question, etched in stone, waiting to see if any echo of its birth survived in the songs of those who first called it home. The channeled Scablands are a geological scream frozen in stone. For the Nez Perce and Yakama peoples, whose ancestral homelands border this scarred landscape, the land does not scream, it speaks. Their oral traditions hold powerful flood narratives, but these are not the universal deluge myths found in many cultures. These stories are startlingly specific, anchored to the very rocks and rivers of their world, and they describe a violence of water that matches the scientific tale of the Missoula floods with uncanny precision. One central narrative tells of a time when the people were warned by the animal beings of an impending disaster. They fled to the highest mountains, and from that vantage point, they witnessed the world below being utterly transformed. The stories describe not just a great rain, but a wall of water arriving with a roar that shook the earth, a force so powerful it tore the land apart. They speak of water flowing with such unimaginable strength that it carved deep canyons through solid rock in a single day, leaving behind dry riverbeds where no water flows today. They recount how the floodwaters stranded huge boulders on hilltops and mesas, rocks that had no business being there, as if giants had tossed them in a fit of rage. These are not generic details. They are exact observations of the Scablands' most bizarre and defining features. The dry waterfalls, like the spectacular Dry Falls, which is 5 times wider than Niagara, are explicitly mentioned in some accounts as places where the Great Spirit's tears or the floodwaters once poured over cliffs before the river found a new course. The massive, isolated boulders of foreign rock, called erratics, which were plucked and carried by the flood, are often described in the stories as the playthings or the weapons of powerful beings during that chaotic time. What makes these traditions so compelling is their localized geography. A universal flood myth might speak of water covering the whole earth, but the Nez Perce and Yakama stories are meticulously place-based. They name specific mountains that served as refuges, like the peaks of the Blue Mountains or the Wallowa Range, which align with the highest ground that would have remained above the floodwaters. They describe the flooding of particular valleys and the rerouting of known rivers, details that correspond to the complex channel networks geologists have mapped. The narrative often includes a crucial sequence: the warning, the frantic ascent to high ground, the witnessing of the cataclysm, and then the slow, difficult return to a world made alien. This structure mirrors the experience of any community surviving a sudden, landscape-altering disaster, the period of safety, the shock of the event, and the challenging aftermath of navigating a newly configured homeland. The stories, therefore, function on multiple levels. They are spiritual accounts explaining how the sacred landscape came to be. They are survival manuals, encoding the critical lesson that high ground is safety when the waters rise. And they are historical records, preserving the sensory and emotional truth of witnessing a geological event of biblical proportions. When a Yakama elder describes the sound of the flood as the thunder of 1,000 buffalo stampedes, or a Nez Perce story details the way the water swirled and cut behind a particular ridge, they are providing a human dimension to the cold hydraulic data. Science can calculate the cubic miles of water per second, but only human memory can convey the deafening roar, the sight of familiar forests vanishing under a churning brown torrent, and the profound disorientation of stepping back onto a continent that has been fundamentally, violently remade. These traditions suggest that the first people to repopulate this scoured region encountered a landscape so freshly wounded, so blatantly shaped by recent and immense violence, that the event became the foundational story of that place. The land itself demanded an explanation, and the memory of its traumatic birth was woven into the fabric of cultural identity, ensuring that even as the waters receded, the story of the flood would never run dry. These stories do more than remember the past, they prepare for the future. The most profound purpose of these ancient narratives is not merely archival, it is profoundly practical. They are not just chronicles of what happened, they are manuals for what to do when it happens again. These catastrophe stories evolved into sophisticated systems of intergenerational risk communication, embedding vital survival instructions within the unforgettable shell of a sacred tale. The narrative itself becomes a delivery mechanism for community resilience, ensuring that critical knowledge outlives any single generation. For instance, many of the Pacific Northwest stories about the Thunderbird and the whale do not end with the devastation. They often include a crucial epilogue, a lesson learned by the ancestors who survived. The narrative emphasizes that when the earth shakes violently and the ocean pulls back to expose the seafloor, that is not a time to collect shellfish from the newly revealed sand. It is the moment to turn and run as fast as you can to the highest ground possible. This exact sequence, shaking, then ocean withdrawal, then a desperate sprint inland, is the precise survival protocol for a locally generated tsunami. The story encodes the natural warning signs and the correct, life-saving response. It transforms a complex geophysical process into a simple, memorable rule, a rule passed down not as a dry instruction from an emergency manual, but as the hard-won wisdom of ancestral heroes who lived through the terror. Similarly, stories of volcanic eruptions often carry specific warnings about the dangers of the ash itself. They might describe the spirit's breath as a gray, choking fog that kills the plants and makes the water foul. Within this poetic description is a critical public health advisory, warning against drinking from ash-contaminated water sources and signaling the coming hardship for crops and game. The story provides a framework for understanding the cascade of consequences, famine following fire, and implicitly guides the community toward strategies for coping, like relying on stored food or moving to unaffected areas. This narrative embedding makes the knowledge incredibly sticky. A list of emergency procedures can be forgotten, but a dramatic story about a cosmic battle between great powers, a story sung and performed regularly, ensures that every child in the community internalizes the warning signs and the escape routes. The taboo, the sacred prohibition, is often woven into these stories as well. Certain areas, like low-lying coastal flats or valleys leading from a volcano, might be described as the resting place of a spirit or the scene of a great loss, making them places to be avoided or treated with extreme caution. This cultural sanction protects the community from settling in geographically hazardous zones, long before the concepts of floodplains or lava flows were scientifically mapped. The story becomes a form of land use planning, guiding where to build villages and where to only venture temporarily. This transforms the narrative from a record of an event into a living, breathing part of the culture's immune system. It is a technology of preparedness, ensuring that the trauma of the past pays forward into the security of the future. The memory of catastrophe, carefully preserved and ritualized, becomes the very thing that prevents the next catastrophe from being a complete surprise. The elders are not just telling a story, they are running a drill, passing a baton of survival through time, using the power of myth to keep their people safe for another generation. For centuries, the keepers of these stories faced a wall of disbelief. When European explorers and later anthropologists first recorded these narratives, they were filtered through a lens of profound cultural bias. The dominant Western worldview of the 18th and 19th centuries operated on a strict hierarchy of knowledge. Written text, especially scientific data recorded with instruments, was considered objective, reliable, and modern. Oral tradition, by stark contrast, was often dismissed as primitive superstition, the charming but ultimately fictional mythology of peoples deemed less advanced. This was not merely academic disagreement, it was a fundamental clash of epistemological systems, of how different cultures define truth itself. The intricate memory technologies, the generational discipline, the place-based anchoring, all of it was invisible to outsiders who heard only what they labeled as simple folklore. A detailed account of a tsunami was heard as a metaphor. A description of a volcanic collapse was catalogued as an entertaining legend. The stories were literally heard, but they were not listened to. This dismissal had a real and lasting cost. Vital environmental knowledge about earthquake cycles, volcanic hazards, and coastal stability was effectively erased from the land use planning of incoming settler societies. Communities were built in tsunami run-up zones, infrastructure was placed on unstable ground, all while a rich library of risk assessment, preserved for generations, sat unread on the shelves of anthropology archives, classified not as science but as story. The paradigm of Western science, for all its power, had blinded itself to a complementary source of data, one written not in numbers but in narrative. The turning point began not with a dramatic announcement, but with a quiet shift in how scientists asked questions. In the late 20th century, researchers like geophysicist Ruth Ludwin and geologist Brian Atwater approached their work with a new humility. Instead of arriving with answers, they arrived with curiosity. Atwater, studying the ghost forests and buried soils of the Pacific Northwest, knew the geological evidence pointed to a massive quake, but he needed a time frame. He turned to the tribal historians of the Quinault, Hoh, and other coastal nations, not to mine their stories for data points, but to listen. He presented his physical findings, the submerged forests, the sand layers, and asked if their traditions spoke of such events. The response was not a single story, but a chorus. Elders shared the narratives of the battle between Thunderbird and Whale, of the ocean pulling back, of the shaking and the wave. They provided not just confirmation, but context, the human scale of the catastrophe that the sand layers could never convey. Similarly, Ruth Ludwin systematically collected and analyzed these oral histories from dozens of sources, treating them as potential records of seismic events. She mapped the stories against the fault lines and found the correlations were too precise to be coincidence. This collaborative listening changed everything. The Japanese tsunami record of 1700 gave a calendar date. The tree rings and sediment cores gave physical proof, and the indigenous oral histories provided the eyewitness testimony that connected the dots, transforming a theoretical geological event into a documented historical moment. This was more than just adding a new source, it was a paradigm shift. It forced a re-evaluation of what constitutes valid evidence and who is considered a reliable witness. It demonstrated that science and oral tradition are not opponents, but partners in a much longer conversation about our planet. The rediscovery of these records is not about validating one system over another, but about realizing that our understanding of the deep past is richest when we are brave enough to consult all the pages of the human record, even those written in the most enduring ink of all, memory. The quiet shift from dismissal to collaboration is now reshaping how we understand hazard and history. This modern partnership is not a one-time validation, but an ongoing, interdisciplinary dialogue. In research centers from the Pacific Northwest to Australia, seismologists, geologists, and anthropologists now sit alongside Indigenous knowledge keepers, not as subjects of study, but as co-researchers. They are building a new model of inquiry where a core sample and a ceremonial song are seen as different chapters of the same story. One powerful example is happening along the coast of British Columbia. Here, geoscientists are working with the new Charnolth and other First Nations to refine tsunami evacuation maps. The scientific models, based on bathymetry and fault mechanics, provide one layer of data. But the oral histories, which describe how far the water reached in specific valleys during the last great wave, provide another, often more precise, layer. A story that mentions a particular ridge where ancestors took refuge gives a real-world, high watermark that computer models might not capture. By weaving these place-based memories into the geographic information systems, communities are creating evacuation plans that are both technologically sophisticated and deeply informed by lived historical experience. This fusion saves lives by grounding abstract risk in the concrete geography of ancestral memory. In other regions, the stories are acting as guides, pointing scientists toward geological features they might have overlooked. For instance, in the interior of the Pacific Northwest, certain oral traditions from plateau tribes describe specific landscapes altered by ground shaking and fissuring, events not tied to the major offshore fault. Listening to these narratives led researchers to investigate and ultimately identify subtle, previously unmapped fault lines on land. The stories served as a prompt, a historical clue that directed technological scrutiny toward areas that might have otherwise seemed geologically quiet. This is not about replacing LiDAR scans with legends. It is about using the long human memory of a place to ask better, more informed questions of our instruments. The collaboration extends to the very language of research. Informed consent protocols are built on respect, ensuring communities retain authority over their knowledge. Data sovereignty agreements guarantee that sensitive cultural information, like the location of a sacred site that also marks a geological hazard, is protected and used appropriately. The goal is a reciprocal exchange where Western science gains a deeper temporal context, and Indigenous communities see their knowledge systems recognized and applied in ways that enhance the safety and well-being of their people today. This convergence is fundamentally changing the narrative. It moves us beyond the old, simplistic frame of science proving the stories right. That framework still places one system in a position of authority over the other. The new understanding is more profound. It recognizes that these are two complementary and equally rigorous ways of knowing the world. Science excels at the how and the when, measuring shock waves, dating ash layers, and modeling probabilities. Oral tradition excels at the human experience, the sensory detail, the social impact, and the long-term meaning of an event. One gives us the calendar date for the Cascadia quake, the other gives us the thunder of the Thunderbird's wings and the community's memory of where the wave finally stopped. Together, they provide a holistic picture that neither can achieve alone. This partnership reveals that our planet's history is not just a record of rocks and forces, but a story of life adapting to a changing world. It teaches us that resilience is not just an engineering problem, but a cultural one, built on the stories we tell and the memories we keep. When a geologist and a knowledge keeper look at the same landscape, one sees seismic risk and sedimentary layers, the other sees a chapter in an ancestral epic. We are finally learning that to truly understand this Earth, we need to read both books. This powerful convergence, however, is not a simple key that unlocks every ancient story. As we stand at this intersection of geology and memory, we must also acknowledge its boundaries and navigate its uncertainties with great care. The most significant challenge lies in interpretation itself. The symbolic language of myth is rich and layered, designed to carry multiple meanings across time. A story about a great serpent could be a memory of a comet, a metaphor for a river, a spiritual allegory for inner conflict, or all of these things at once. The danger for researchers is the temptation of what is called confirmation bias, the eagerness to see a desired pattern everywhere. We must resist the urge to force a geological explanation onto every narrative, to turn a rich cultural tapestry into nothing more than a primitive scientific report. Not every flood story records a post-glacial sea level rise, and not every tale of a fiery mountain needs to be a volcano. The argument is not that all oral traditions are literal geological records, but rather that many, when understood in their full cultural and geographical context, contain a verifiable kernel of historical observation. Discerning that kernel requires immense patience, deep cultural literacy, and a humility that accepts some stories may forever remain beyond our literal translation. It is the difference between listening to understand and listening to extract. This work demands we recognize that the primary purpose of these stories is not to inform future geologists, but to sustain the identity, lore, and spiritual life of a people. The geological truth, when it is present, is woven into that larger purpose, not separate from it. To pull at that single thread without understanding the whole fabric is to risk unraveling the meaning entirely. This leads directly to a vital and valid concern held by many Indigenous communities. For centuries, their knowledge has been extracted, often without permission or proper context, by outsiders who treated it as mere data to be mined. Sacred narratives, stripped of their ceremonial significance and owned by the people who tell them, have been published, analyzed, and sometimes distorted to fit external agendas. This history creates a rightful skepticism about new forms of interest, even those that come with respect. The collaborative model emerging today seeks to address this by ensuring that communities maintain sovereignty over their stories. It means research proceeds with consent, that knowledge keepers are recognized as experts and co-authors, and that the benefits of any discovery flow back to the people whose heritage made it possible. This is not just ethical, it is essential for accuracy. Without the guidance of the culture that curates the memory, an outsider can easily misinterpret a crucial detail, turning a profound truth into a scholarly error. The goal is partnership, not possession. It is to walk alongside, learning how a people remember their past, rather than taking that memory and claiming to understand it better than they do. This respectful approach reveals the true strength of these traditions. They are not fragile relics to be decoded and shelved, but living, adaptive systems of knowledge. Their power lies in their holistic nature, binding history, morality, ecology, and identity into a single, resonant narrative. When that narrative also carries a record of an earthquake, it does so not as a standalone fact, but as a chapter in the ongoing story of a people's relationship with a powerful and sometimes perilous land. The verification from geology does not reduce the story, it amplifies our awe for the system that preserved it. It shows us that human memory, when cultivated with purpose and reverence, can achieve feats of longevity we once thought impossible. So the question is not whether every ancient myth hides a scientific secret, but how many other windows into the deep past have we closed because we did not know how to listen? This synthesis of story and stone reveals a truth far larger than any single event. We are looking at a parallel historical record, a long-term data stream of planetary change, maintained not in libraries or on hard drives, but in the collective memory of cultures intimately tied to their land. For millennia, Western historiography has operated on a simple, linear assumption. Recorded history begins with writing. Everything before that is prehistory, a vague and shadowy realm pieced together from fragments of pottery and stone tools. But what if that framework is not just incomplete but fundamentally flawed? The evidence from Cascadia, from Crater Lake, from the drowned coastlines of Australia, suggests that human societies have been meticulous chroniclers of their world for far longer than we ever credited them for. They developed a sophisticated methodology of memory, using place, song, and ritual to encode observations with a fidelity that can survive for hundreds of generations. This is not prehistory. This is a different kind of history, one written in narrative and anchored to geography. It represents a vast extension of the human environmental record, pushing our detailed understanding of catastrophic events back thousands of years before the first seismograph was ever invented. The implications are profound. It forces a complete reevaluation of the intellectual and scientific capabilities of pre-literate societies. They were not simply surviving in their environments, they were studying them, analyzing cause and effect, and devising systems to preserve that hard-won knowledge for the benefit of descendants they would never meet. This was a science of observation and transmission, with its own rigorous peer review conducted across generations in the ceremonial space. Recognizing this shatters the old hierarchy that placed written text above all other forms of knowledge. It reveals that humanity has possessed for a very long time a powerful tool for understanding long-term geological risk. Our modern instrumental records, for all their precision, are blinkered by their brevity. A seismographic network might give us a century of detailed data. A tide gauge might show a few decades of sea level change. These are invaluable, but they capture only a snapshot of a planet that operates on cycles spanning centuries or millennia. They can show us the symptoms, but they often miss the full rhythm of the disease. Oral traditions provide that missing context. They offer a baseline of normalcy and a record of extremity that instrumental science can only dream of. A story that recounts the shaking, the drop, and the wave gives us not just proof of a past megaquake, but a template for the sequence of the next one. A narrative describing the slow drowning of a coastal plain provides a human-scale timeline for sea level rise that complements the abstract graphs of core samples. This partnership between deep memory and modern measurement creates a far more robust and resilient understanding of the hazards we face. It allows us to plan not just for the disasters in our grandchildren's lifetimes, but for the cataclysms that return every 500 years, events that would otherwise be statistical ghosts outside our historical horizon. We begin to see that the oldest stories among us are not relics. They are early warning systems patiently maintained across the ages, waiting for a time when we would be ready to listen. The evidence is now undeniable, a chorus of truth sung from the land itself. From the ghost forests of the Pacific Northwest to the deep blue caldera of Crater Lake, and across the sunken plains of ancient Australia, specific indigenous oral traditions have preserved the precise details of catastrophic geological events across spans of time that stagger the imagination. These are not vague legends of floods or fires, but meticulous records that match the timelines and physical mechanics uncovered by modern science. The Great Earthquake of January 1700, the volcanic collapse 7,700 years ago, the slow drowning of coastlines after the Ice Age, these events are held in memory with a clarity that bridges hundreds of human generations. This convergence is not a coincidence, it is the result of sophisticated, intentional systems designed to outlast time. The disciplined training of knowledge keepers, the mnemonic power of song and ritual, and the profound encoding of stories directly into the landscape itself created a living archive. Most importantly, this knowledge was woven into the very fabric of cultural survival, transforming past catastrophe into future preparedness, ensuring that a community would remember not just what happened, but what to do when it happened again. This reality reshapes our understanding of human history. It tells us that detailed environmental records extend thousands of years beyond the written word, preserved in a durable medium of narrative and place. For geology, these stories provide a human-scale context for events that science can date but cannot feel, offering eyewitness testimony to planetary processes we can only model. This demands a fundamental shift in respect, recognizing indigenous knowledge systems not as primitive folklore, but as parallel and equally rigorous sciences of observation, interpretation, and intergenerational transmission. Their truth was always there, waiting in the stories. The question now is how we listen. Around the world, countless other oral traditions hold the history of their homelands, stories of mountains that walked, stars that fell, and rivers that changed their course. What if we approach these narratives not as simple myths to be dismissed, but as potential libraries, as coded messages from the deep past? Each one could be a key, waiting to unlock another chapter in the epic story of our dynamic planet and the resilient people who have witnessed its changes. The invitation is to listen with new ears, to hear in the oldest stories not just poetry, but the enduring memory of the earth itself.